Well, hello, hello. How's everyone doing tonight? I forgot to put up the poll for y'all to start voting, so I need to do that in a second. I see people coming in from Scotland. I got Florida. I see France, England, Canada, Australia, New Zealand. Hello, everyone. Let me get this poll put together real quick, and then we can start chatting here. I hope everyone's doing all right. Almost there. All right. Of course, it's too long here, some of these words. I have to shorten it up a little bit. All right. There we go. All right, sorry about that. I should have got that set up ahead of time. Well, let's see. We got Chicago here. We have Montreal. We have Plano, Texas, Southern England. How's everyone doing tonight? I thought it'd be kind of fun. Do we have a lot of people here who was here from last week? We had a pretty fun repair. We had couple different repairs we did last week, but one of the main ones, one of the highlights, was Bob's modem laptop. Bob in the chat chimed in, said, "Hey, I got a repair that's in your repair department right now." And I went and grabbed it, and we opened it up and took a look at it, and it was actually pretty bad. He had spilled some coffee on it or soda or something like that, and damaged it to the point where motherboard repair was not really going to happen, and everyone kind of voted, contributed money, and was able to help get his laptop fixed. So let me pull out his laptop real quick. So I have his laptop all together, and what we ended up putting in here, he had an i7 with a 2070, RTX 2070. I could not get one of those. I didn't have one of those. But what I did have was an i9 with a 2080 Super. So that's what he got. Bob got an upgrade. And because of your donations, I was able to give him a good deal, and we got it all fixed up. Now, all of this was damaged. It was sticky. I was able to clean it all up, and so he doesn't have to get that replaced. We're trying to keep the budget down. He is on a limited budget, so that's what we had to do, is kind of keep all the parts that he could. And so I just had to clean up all the stickiness, and all the keys work, and the power button works after I cleaned it. So yeah, so Bob's Margarita laptop is good to go, and you can see that he has a few different peace and love stickers on there. So that was a fun one, and I don't know if anybody else in the chat tonight is going to be like, "Hey, I have a laptop there. Can you fix it live?" But we did put up a poll that you just vote for, and it looks like so far the Precision 5530 doesn't power on. Is going to be the winning. The rest of them are going to be like the 9310. That one is, the USB ports are loose. You just kind of like wiggle them. It will charge in different positions. The 9520, his notes are a little more elaborate than what I put in there. So it says BIOS firmware update, and I can actually tell you what his notes are, because that one could not be a BIOS issue. We don't really know at this point. I mean, I haven't looked at it, so I don't know. He kind of wrote a book here, but it says, while performing a firmware update with the power supply connected, the laptop bricked. He noticed that the power supply standard USB-C charger was connected to the right side, and then the light at the other end of the cable went out. He believed the laptop died during a firmware update from lack of battery. He discovered the USB adapter charger was damaged because of a chair rolled over it. So I don't know. He's kind of doing the diagnosing for me, so it doesn't really mean that it's a BIOS issue. That's just kind of something that to take note of. It's something that he diagnosed. So anyway, so you guys cast your votes now. We'll work on it. Did everyone see that video I put out a couple days ago? I think it was yesterday, actually. The 7670, I think is what it was. It was a Precision workstation. Had a shorted EC chip. That was pretty interesting. Let's see. It was the worst laptop I ever worked on. Man, you got to... Let's see. What else we got going on here? Hello from Florida. How many people do we have chatting right now? So we have 186 people in the stream, and we have 106 votes. So y'all are doing pretty good. So I'm going to leave the votes up for another 5 minutes or so. That way we can get all the votes in. But it does look like it's kind of slanted towards 72% for the 5530. So we probably will just get going on that sooner than later, because I don't think the other poll is going to, or any of the other laptops are going to win. Does this laptop, or does this Bob have a laptop to be repaired? So Bob had his laptop repaired last week, and so I was just kind of showing the update. It's all working now, so we're all good to go on there. I was going to ship it out tomorrow to him. So that one, and if you notice his note, he said check the modem. Well, he was actually talking about his Wi-Fi card. One of the antenna brackets was actually bent, so I had to bend that back and fix it so he can hook an antenna up. So. But I'm looking at this. We got Precision 5530 winning at 71%. I think that's going to be the winner. What do you think, guys? I don't think that we should even wait any longer. That's out of 112 votes. Yeah, that's what I'm thinking. Let me pull it out. We can take a look at it real quick. I can close the poll out. There we go. There's the stats. All right, sorry, I had to grab it. Okay, looks like it has a cover on it here. Let me make sure that we don't have any personal information anywhere. We're good to go. This thing has seen better days, it looks like. He has some sort of sticky skin or whatever on the front and the back. That's why it looks a little more scuffed. But that doesn't change what it is inside. It has a note here that says, does turn on, battery does not charge. Okay, so I guess it powers off the battery, but it doesn't charge or turn on the laptop off the charger. So we have some sort of issue with the charge circuit probably. Probably not a short on the board. We could have a short somewhere in the USB-C PD controller or something like that. PD stands for power delivery, which is how these machines have two USB-Cs on one side. Wait, oh no, this is an older machine. This is the 55, oh, ooh, interesting. All right, this got a little, okay, so this is a Precision 5530 last generation. So they have a Precision 5530 that came out in like 2023. This is the older version of this, so they would call this end-of-life version of it. So this one has a barrel jack here, and it has the USB-C. Okay, and so I've seen these over the years get damaged where they don't charge off of the barrel jack, and so I think I know exactly what's wrong, and we will be able to get right to it and fix it really easily. I need to update our title here real quick of what we're working on. So let me get that updated real quick. right. So now we actually have it where it puts it on the bottom so people don't have to ask over and over again. So we are working on a Dell Precision 5530, doesn't charge the battery. So first thing we want to do, let's just go ahead and see if it powers on. They said that it does power on, so we're going to just press the power button and see if we get any power lights. It's probably dead. I'm not seeing the keyboard backlight come on or anything like that. So nothing's happening there. Now we do have our power meter here. Off to the side, you can kind of see it in this overhead shot, and then I just have this other camera looking at it. So the power meter is just it's a box that I made, and you can plug in a regular Dell charger into the back of it, and then it gives us both cords that we need for Dell charger or Dell laptops. So we have the 7.4 inch and we have the 4.5, not inch, 7.4 millimeter and the 4.5 millimeter. So on this machine, we're actually going to use a 4.5 millimeter. This allows us to see how much current and voltage is going into the laptop, how many watts it's using, and will allow us to detect or identify what we're seeing is wrong with the laptop. So here we go. We plugged it in, 0.01. I'm waiting because I want to see if it starts triggering a charge or anything like that. It's not. But we are pulling 0.01, so we know that the DC jack's actually getting power to the board. We know that something's going in there. So if I open the laptop, did it do anything different? It didn't. So we're looking for that Hall effect sensor to trigger something on. Now I'm going to hit the power button and see if it pulls any current, and it doesn't pull any current. So the initial issue that I was thinking it was going to be is not that. So there is a known issue, or a known issue by us at least, or me, that on these machines that if you use like an aftermarket charger, you can end up blowing out this one, it's like a 33 ohm resistor that's on the PSID line, which is the communication line where the charger communicates with the laptop. And it blows that out and it doesn't allow it to communicate anymore. But this laptop should still power on with this. But because we have a USB-C port on here, this laptop will run off a USB-C port. So there's a chance that this thing will just turn on with this. And we just move on with life. All right, 0.02. And if we press the power button, nothing's happening. All right, so what that means is that if the USB-C port doesn't work and the barrel jack doesn't work, then we have some sort of issue with our power management system or the charge system. So we probably have a bad power management chip on here. So let's get the bottom opened up. And I pulled out my T5 screwdriver to open this up, but the screws that are in there are Phillips. So somebody has switched out the screws. You want me to wiggle the cord, Carl? Yeah, let me show you. If the USB-C doesn't work, then it's not going to matter to wiggle the cord. But it's actually really tight. You can, I guess I can wiggle it to the side a little bit, but it feels like a really tight connection here. I have extra DC jacks we can plug into it. Do you guys think this is going to be an easy pizza if it's not charging? I guess if it's a power management chip, that does make it a little easier. Oh, it does charge battery? That's funny, thank you. Oh my goodness. Much better? I wish you guys could do that stuff for me. I need somebody else that does all that, the side stuff. What other questions you have? Piece of cake, piece of cake. Is there any specific brand or type that you recommend for CPU or GPU thermal paste? So what I'm going to, for any of the higher end machines, the gaming machines, you could just do, it's PTM 7950. I actually bought like a huge sheet from LTT.com, which is the Linus Tech Tips. And so that's what we use if we're going to be, oh, here it is right here. This is phase change. So essentially what it is it's a sheet of thermal paste. And when you put it on the GPU and CPU, it liquefies whenever it heats up. And it's pretty much the best thing at this point, besides liquid metal, which we hate liquid metal, so we're not going to speak that word. Yeah, the reason why this laptop looks so messed up is it is just the skin that's all scratched up here. This is actually textured. It almost feels like it has ribs on it, something like that. So we're going to try to figure out why this laptop does not power on or charge off the battery. I mean, off the charger. The battery apparently works fine if we plug in a regular battery. All right, so this machine, if we take a quick look around, this machine was actually made to, you can put a 3-cell battery or 6-cell battery. So this one has the 3-cell battery. And if you have the 3-cell in here, you can put a 2.5-inch drive. If you put the 6-cell in here, then you lose that capability. So this one has a spot for a 2.5-inch drive. So 2 sticks of DDR4, there's the NVMe drive there. And I can grab a test battery. Let's go ahead and grab a test battery, plug it in, make sure the thing turns on real quick. So here is a test battery. And looks like they damaged their connector here, but that's fine. It can still plug in. All right, I'm just kind of setting it on top. Yeah, Honeywell makes the PTM 7950. Thank you for clarifying that. I just bought it from LTT.com. Or LTT, what is it? Linus Tech Tips, whatever his, that YouTube channel. All right, so I pressed the power button now with the battery plugged in. I don't have a charger plugged in, but we are getting a power light. I'm gonna go ahead and plug in the charger too while we're at it, just to see if it does anything different. Excuse me. So we still are pulling that 0.01, so it's not charging, but it is powering on. And it is going into the BIOS. And it's thinking about it. Okay, let's see if we can see the battery meter. Running really slow. Okay, so AC adapter not installed is what we have showing up here. If we can see that. Here, oh, sorry about that. We'll see if we can zoom in just a little bit. So AC adapter not installed. That's on the barrel jack. I'm going to plug in the USB-C also and see if that changes. Either one of these should charge. They should be recognized, and it's not doing anything. So we know that it's not, the voltage is not getting somewhere, or it's not being able to communicate with the EC chip or the power management chip or something like that. And our battery's at 71%, my test battery here. So. Okay, so what is the issue? Can we do anything without taking out the motherboard? Probably not, especially on this machine. So most of the stuff's over. It is on this side, so we can actually take a look at it. But I know where the power management chip is, and it's not on this side of the board. So, and I can explain what a power management chip is here in a second. So I have the battery unplugged, so I can unplug the LCD screen. For those who have never worked on a laptop before, if you mess with the LCD cable or plug in the LCD screen without unplugging the battery, you risk blowing out a lot of different things. So always unplug the battery before you mess with anything. It's just good habit. Let's get under the microscope. So there's that battery connector. It is actually busted on top. The plastic on top is not connected anymore. So what we're trying to get to under here, under this plastic film, is going to show us the charging circuitry. Let me get it peeled up out of the way. All right, so sorry about that. Trying to get this adjusted perfectly. I don't know why this isn't focusing all the way. All right, so here's where the DC jack plugs in to the motherboard. And so what we're going to be looking at is that it comes in here. We have 3 negative, 3 positive, right? So we got our ground and going to be our 20 volts or 19.5. And then this is our PSID pin we were talking about. So what that is a communication line between the charger and the laptop. And so the laptop can know how many watts the charger can provide. If it can't detect that, a common thing on this machine is that it can't detect this, so it will say unknown adapter. And then the laptop will actually run at like 300 megahertz or something like that, something really slow. It also won't charge the battery. So I'll hear people call me and say, my laptop's running really slow and it's not charging the battery. So those are the two scenarios or two things that automatically tell me that the PSID pin is not communicating. So you would either replace this DC jack, or it's going to be on the motherboard, and there's going to be this resistor that blows out all the time on this board. But because the USB-C port's not working, that has eliminated those two things as being the issue. And this is the PD controller for the USB-C port. This is what actually does the communication. So the way a USB-C charger works is it starts at 5 volts when you plug it in. It negotiates up to 20 volts, and then it will pull how much current it needs. So that chip's probably fine, because when we plugged in the charger, if you noticed, the USB-C charger, right now, it will start at 5 volts when I plug it in, and then it jumped up to 20 volts. You see that? So that's what we're looking for to see if the PD controller, the power delivery controller chip is working. So we've eliminated those two things. The next chip over here is going to be the Thunderbolt chip. This is just handles all your Thunderbolt USB 3 communications. So why do we have this piece of plastic? Is going to make me get mad. It keeps flipping into our way here. But I'm looking at this solder ball on here. You see how this looks a little bit bigger than the rest? That's strange. So anyway, all these MOSFETs are controlled by a chip called the power management chip. So after the voltage comes into the machine, it's going to be going to a set of MOSFETs, which I believe they're over here on this one. You can see a bulge. Comes through here, comes through this one, and then it will create the main power rail, which on this machine I believe is 13.6. I think I'm right on that. So I think we should have 13.6 volts on this main power rail, or which is going to be on the battery power rail or charging circuit. But it's going to come through this current sense resistor. So let's plug in our charger again, and then let's see what voltage we're getting over here. Are we sure this laptop's worth 140 bucks? Yeah, so if you look it up, the motherboards are actually still kind of pricey if you look to try to buy one of these motherboards. That's why what we do is whenever we are letting a customer know that we need to put this in motherboard repair or not, because my motherboard repair is a flat $249, and it includes return shipping as a year warranty and things like that, but whatever's cheaper. So if we can replace this motherboard for less with labor and all that stuff, then we usually go that route. Otherwise, we do the $249. We give them an option. We let them know, like, here's the price of motherboard replacement, and or here's a motherboard repair. All right, so we're going to pull up our meter. I just want to see how many volts we're getting into the board. So we can start over here, DC jack. We should have our 20 there. There's our 20. Does everyone see that at the top up there? So right there. And it should come all the way over here. Let's see if we're getting, and we're not getting it there. I can't remember. It's been a while since I worked on this machine. So we have our 20 volts. We're getting 19.8 here. Sometimes what you want to pay attention to, you see how we have a little bit of a voltage drop. So it's at 19.8 here, but at the jack, we have 20 volts, 20.1, right? So we're losing 0.3 volts. So we may have an issue somewhere on a MOSFET that's leaking a little bit of voltage. Cheap, only $249. Yes, it is cheap. We don't really make any money in this department, I can tell you that right now. So sometimes I spend too much time on this stuff, but it's all for entertainment for the most part. So what I'm looking at here is we have our voltage coming to this side of this MOSFET. For most people, I don't know how many people are familiar with a MOSFET. It actually is basically just a switch. That's all it is, right? So on this type of chip, this type of MOSFET, you have 4 pins on this. This is the input. We have 3 pins on the output, and then we have a pin that's our trigger pin. That's our gate pin, okay? So if we want to, I think if this one is low, if it's high, then it allows voltage to flow. I can't remember how it's set up on this. Well, it's low right now, so there's nothing coming through. So But anyway, so you basically will either put a high voltage or a low voltage on that gate pin, and it will allow the voltage to flow. On some of these MOSFETs, they're going to be pulsing it with a PWM signal, so it comes on and off really fast, and that's going to allow only a certain amount of voltage through at a time. So, but right now we don't have the voltage. The machine is not allowing the voltage to flow. Well, the chip that controls this is going to be the power management chip, and so that's why I think, because we're not getting anything through there, we automatically know that it's most likely the chip that controls that. So let me pull the motherboard out, and we can look at the power management chip. We can take some measurements around there, and then we can continue testing. And it doesn't take that long to pull this board out, so I can do it with my eyes closed. Could it be a capacitor? Are we talking about a short on the board capacitor? Right now, I don't think we have a short. I guess we can measure in this area. But generally, if the laptop's turning on, so we have that side of the, think about it as kind of like the laptop set up separate, you know, two different areas. So we have our charge area, the voltage coming in, and then that handles the charging of the board, handles the USB-C power in and all that stuff. And then you have the other side that actually runs the machine. And then there's one MOSFET that kind of jumps between the two. Though, if the board's turning on and posting and all that, we don't have a short on the board there. And on this side, I mean, I guess we could have a short on a capacitor. I've seen them like on the VDD, which is the line that powers the power management chip. I've seen a short on that before. But so we're going to put our meter in continuity mode where it beeps if we touch the probes together. And we can just start kind of probing around here. But I doubt we're going to have a short over here. I don't see... Yeah, it's beeping for a second and the capacitors charge up and then it stops. So we're doing fine. I don't think there's a short there. I'm going to pull this board out. It doesn't take very long. You guys ask some questions while we're at it. Is the jack plugged in all the way? It doesn't really matter if the jack's plugged in all the way because the USB-C port doesn't work. So remember, we have two different ways of charging this machine and powering this machine, and because the USB-C port's not working, yeah. Did I test this battery? It doesn't turn on with this battery. So their battery doesn't turn on because it's probably dead. And it is an aftermarket battery or a fake battery. But I plugged our real battery in there. The machine did turn on and was able to, we were able to get into BIOS and everything like that. Thank you for explaining and teaching and showing. You're welcome. I enjoy it. These live streams are actually a lot of fun. Every time I'm done with one, before I start, I'm kind of nervous. I don't know why. And at the end, I'm always like, wow, that was a lot of fun. And I hope everybody else has a lot of fun. I kind of like the, whenever somebody chimes in is like, hey, work on that machine. I have it there. And I was like, that sounds like, yeah, the roulette of it all. Is Bob here? Bob, how you doing? Can you run it without the battery? No, the machine does not power on without a battery in there at all. So it's, oh, we're missing some screws. Somebody has already taken out some screws out of this machine. Yeah, so the machine only works on battery, and that's it. Yeah, most Dell laptops, except for like the really tiny ones, usually like the 13-inch laptops, will run without a battery. So you could just, if I just, on this machine, because the way that the EC works, it will just power on right as I plug it in. So if I just plug that in like that, we should start seeing current being pulled right there. And you see it's just sitting at 0.02. So the machine's not powering on. Now we could have a dead CMOS battery, but we wouldn't have a dead CMOS battery because it powers off a battery just fine. That's a regular battery. So see, again, all this stuff is all clues. And so the fact that the machine runs just fine off a battery means that we have a charging issue, charging circuit. And it's going to be probably the power management chip issue. So, how many old donor machines do I have in the shop? So, donor laptop, like I have one of every machine as a test machine. So we probably have, I don't, it's like 180 machines, I think, that we have. We have shelves that are all labeled with every single model in order. And we even go back to like C-series stuff, which is like early 2000s. And then I have for like I mean, we have 700,000 parts in the warehouse, so it's not like I don't need a lot of donor stuff for that. We just go out and You know, like this motherboard we have in stock, I can just go grab one from the warehouse. But as for behind me, those are all donor boards, motherboards that I can pull parts off of. And so that's kind of what you might be asking. And I probably have 500 at least donor boards, because I have a warehouse full that's of stacked up boards, but these are all the higher end ones or gaming ones and things like that. How many laptops am I fixing today? So right now we're starting with this one, and it depends on how long it takes. And if this one's really fast, then we'll start on the next one. You know, it's all an adventure. All right, so the motherboard is out. So on this machine, we do have the CMOS battery in this area, but we know the CMOS battery shouldn't be dead. It should be fine. But on these machines, because it has a CMOS battery, if you ever have an issue where the machine won't turn on and it's kind of dead, what ends up happening is because the CMOS battery gets into like kind of the in-between state of being fully charged, which was 2.8 volts and above. It's kind of our safe spot. And if it's, a lot of times it'll be like at 1.5 volts or not all the way dead. If it's 0 volts, then everything will be fine. And if it's all the way charged, everything will be fine. But if it's in the in-between state, then the machine won't turn on, because you'll end up getting, this is what keeps the real-time clock inside the inside the EC chip. And the EC chip is a embedded controller that runs a loop of code that runs a bunch of GPIOs, general input and output. And those are looking for power button presses and keyboard and things like that. And whenever the CMOS is cleared, when you unplug the CMOS battery, it clears that EC chip. And then whenever you plug it in, because the EC chip's cleared, the power button doesn't work anymore. So it has to turn on automatically. And that's how you know if you have a motherboard that programs the EC by itself, is if it turns on automatically when you plug it in. Okay? Just so, because I know a lot of people ask me, and it's like, does this EC auto program or not? Well, if the machine turns on automatically when you do a CMOS reset, yes it does. Because it has to, because there's no other way to turn on the machine. So I'm just measuring the voltage on here, I just want to see. 2.6 volts, so we're on the low side. I would recommend CMOS battery replacement at this point. It has been sitting for a while. These are, well, it's 2019, yeah, so this is a 6-year-old battery. So I would recommend replacing that. Now, this voltage won't allow it, won't prevent it from coming on, but the machine was powering just fine on battery, on regular battery, so I don't think that's gonna be an issue. All right, so this is the area we're trying to get to, and boom, Bob's your uncle. This is the power management chip. This is the chip that's in charge of controlling all the MOSFETs on the input, right? So it handles all the charging of the battery. It handles all the voltages going into the main power rail, things like that. And what do we see there? Right? Bam. That's right. So this, you could call it easy pizza. Just assuming that nothing else burned out and we don't have a burnt trace. I'm looking at this pad in this corner here, see if we can get focused good enough. We might have an issue with that pad down there when we're taking this off. And you can almost see that the solder remelted itself. And you see solder balls back there. So there is a major issue, and here's what we do. So I have brand new 88738Hs, I think I do. So let's look at those, make sure I have some. Yep. So I have a pack of those right here. So we'll be able to change those out, no problem. Now, will it fix our issue? Probably. I would hope so. That would make it a lot easier. So let's get this chip removed and then replace it, clean it up, do all that fun stuff. Well, when we pull it off, I'll make sure there's no other short in that area. Now, if we look what it's actually, that corner's connected to, we see a bunch of vias there. That's going to be this area right here. And I know that, yeah, this is going to be the main 19 volt supply coming into the board. And if you don't know what a via is, it's these little dots, and what it does is it basically ties one side of the board to the other. And so it allows it to pass voltages through the board. Sometimes it passes it to other layers, sometimes it passes it all the way through. But this is a big pad, and it has a bunch of vias, which means it's carrying a lot of current. So that's why that chip burned up. But we'll get it changed out real quick. So I always put flux on one side. People ask me, why do you do that? So I'm not one of those people who put a bunch of flux on top of the chip. How is this going to do anything? What does that do? Nothing. But if I put it on this edge and this edge, this is the orientation where I'm going to be blowing. So I always blow this way, the air, and then it pushes it where I need it. So, you know, I don't know. That's just me. So we're going with hot air station, and I'm using 450 degrees C and 60% air. And we're just going to get in there and get out of there. Although I just noticed this before I do this. And then this is my fume extractor. So if I'm blowing this way, I'm going to end up blowing onto this board right here, which is the audio board. And it has like plastic or just like this film on there, and it's going to start kind of melting. I can just turn the board around this way and then blow this way. And that would be better. I'll have to move that flux over to the other side, but that would be better. So that's what I'm going to do. So I don't have to take that little board off of there. Okay, so we will reapply to our little edge, and now we have it everywhere. Just the way we like it. Here, let's just blob it all around. So why are we using flux? It's basically allows the solder to flow. So if you're if you've ever soldered before and you're like, I suck at soldering, get some good flux. This is Amtech flux, and you'll be a really good solderer. So anyway, we're going 450 C, 60% air. I'm just going to kind of preheat this area. We're melting the flux. Just preheating the area just a little bit. And once we kind of get the whole area heated up, then we'll go in with direct heat. Yeah, that's a lot of flux. I never put that much flux. I usually only put just a little line right on here on the side and on this side. But because I turned the board around, it ended up being a lot of flux. Wait, that's a Rossmann. Yeah, Rossmann, he's a crazy piled up. So did we notice that all these pins became shiny? That's how we know that it's already loose. Ooh, and you see that corner is stuck. This is what I'm afraid of. So we got to be careful. I can't get that corner to come off, and I don't want to break a pad. So I'm just going to try to slowly get it to come off. Oh, we might have an issue, guys. We might have an issue. I'm trying not to pull hard, but I don't want to heat for too long either. But you see how it's stuck here? Yeah, that pad is starting to act a little weird. What about this one? Okay, we got it. Okay, cool. Lift it up out of there. So there we go. Simple. When I say 60% air, let me show you with my camera. So here's this is my hot air station. And so when I set this, I can actually set the airflow. So I can go up and down with my airflow. So 60% air is just like how hard that I'm blowing the air. And then I have my temperature. So a lot of people will say, well, what do you have your settings at or whatever, you know, so that's why I kind of repeat that stuff. But so in general, I usually use 450 with 60%. Sometimes I'll do a 400 at like a lower percent, like 40% air. That's if I don't want chips to blow away. It starts, 60% has a lot of air pressure and you'll start blowing chips away. And then I have like a lower 300 that I use sometimes, like if I'm doing USB-C ports and things like that. I don't want to melt any plastic. So, so let's clean this up. This is cooled off enough. You don't want to put alcohol on here right away, but I'm going to try to clean up this stuff, and then we're going to come in here. You can see this pad did lift a little bit, but we're okay. I'll show you a little closer, but let me get a toothbrush in here too. I'm just try to get some of this stuff off of here first, and then we're going to fix it all. And I'm trying not to go against. I don't know if you can see that pad lifted up there, right there in the middle. I don't want to go against the grain here on this one, so I'm only going this way with it, and we're going to try to stay that way, and I'm going to try to lay that back down. Because again, this is the main 19 volts, so this is what's going to be sending the voltage to that chip, and then that's what's going to be charging the batteries and all that stuff is going to go through this chip. I've got to turn on my soldering iron. Okay, so we're going to put some fresh leaded solder on here. And I'll check the chat while the soldering iron's heating up. The flux I use, I bought it from, it's Amtech 559, I think is what it is. This is Amtech 213, but you can get 559 too. Anyway, both of these, I got this from Northridge. I bought a bunch of them a while back, so northridgefix.com. But it just depends on if you want to support him or not. It's easy to buy counterfeit flux, so you got to be careful. So you want to make sure you're buying real Amtech flux. So I just end up buying it from him. It's fine, you know. All right. We are going to put some fresh soda on here. Dip the entire board in the flux. Yeah, inside the video description, I put a link to all my supplies. And I don't think I have flux in there because I don't really have a reputable place. I mean, I can give you a link to Northridge Fix, but I don't know. And I know there is some on Amazon, but I don't know if it's real or not. So, that pad just fell off. Did you see it come off? I just kind of just barely touched it and it fell off. So it was already very on its way out. So that's no bueno. And that carries a lot of current. So we're going to have to figure out what we're going to do here. My second choice for flux, I don't know. I don't know. Not AliExpress flux. Just try to buy real stuff. It's not super expensive. If you're buying it once and then you just have it, then you're good. You know, I used to use these flux pens all the time. Let me see. These are flux pens, and then here's another flux I actually have. I don't use it very often because it's the Metcal, or no, or MG chemical flux. And this one is just kind of sticky and dirty, and so you have to clean it up immediately or it makes a mess. This flux pen's pretty good. You can just kind of like dab it on the spot. So this is real simple to have. Like, this is what I have at home. So when I'm just soldering at home, I just use that type of thing. Yeah, I don't know how I'm going to rebuild that pad yet. We might use a proper calibrated wire. I don't know. I still have half the pad there, so we might be able to get the chip closer to that side. We also have this huge, let's see. Can't tell if that whole pad is there or not. Can't tell if you can tell. We're going to have to figure out where that goes. I think it's going through that resistor. It might be going through this resistor here. And then having a capacitor. Oh, so that's a ground plane. I was saying that's a 19 volts, but it is a ground plane. Let me clarify what I mean by that. So I thought that this was a 19 volt power rail, but it's actually the ground plane because we have, I think we have, this is the 19 volt pad right here. Comes through this resistor, 0 ohm or 1 ohm, what is it? 1 ohm, 10 ohm. And then comes across here. This is just tied to ground. So this is our 19 volt line right there. What would you do? I don't know. I don't know what I'm going to do yet. I'm thinking about it still. I mean, I have traces I can put on there. It's just whether I'm going to be able to carry enough current. That's what I was thinking about. So I have these little trace pads. This little kit right here. I don't have a link to this. I'm showing you stuff I don't have links to. That's funny. But these traces are tiny. I mean, it's like super tiny. Let's see. So these are circle. I've got some, yeah, there we go. Rectangle right there. So if I try to compare the size, that might be the right size. Yeah, I'll be able to use that. See if I can get you a little closer. Okay, so there's that. And there's that. Yeah, we can put the other half of it there. Yeah, let's do that. Are we good? You guys agree? I'll pull one off and I'll show you. So we're going to just grab one. Oops. Did I get it? Where'd it go? So we can just solder it on like that. Across there. This way. And boom. Yeah, that's actually a perfect size. So that's what we'll do to fix that pad. We have to be a surgeon though. Whenever we're working with something so tiny, do you guys even understand the size of this? Here we go. Let's see. I'm going to do my finger. We'll zoom out a little bit. There we go. Oh, can't even get in focus. Oh no, I lost it. I can't get it in focus enough to show you, but it's small. There you go. So that's the size that we're dealing with, okay? So we're at almost 90x, maybe this is a 90x microscope. I usually I usually am about like 60x or something like that. So we are working very tiny. Okay. It's like a surgeon. So we should update the little message. Looking at a Dell Precision, it won't charge battery. What should we do? Someone post a comment that explains what I'm doing right now, and I'm going to pin your comment, but you know, make it where everyone would get some good information out of it, and then I'll pin your comment at the top. Oh no, it flew away. There it is. So I'm just going to put some flux on here. It's going to make it a little stickier, and then we can hold it down. I'm not even going to worry about trying to solder mask it in place or anything like that, because I think we'll be fine once we get it held down or soldered in place. So let me first, I'm going to get solder on all these pads. Just fixing things on the microphone. That's hard. Oh, I kind of like that one actually. Oh my gosh. Oh, you guys are so funny. Dell Doctor Surgeon. Yeah, JFix, you could do it. Okay. Anyway, sorry. I'm going to stay focused here. I know it's kind of boring if I start kind of looking at chat and doing whatever. So what I need to do is I need to pre-tin all these pads. And pre-tinning is just the act of putting solder on them and getting them ready for the ship. And I need some air because I'm going to die if I have to breathe this in. Replace ECG. Oh gosh. You guys crack me up when I'm reading the chat and trying to focus on repairs at the same time. I don't want that much in the middle. You can put a bunch of solder in the middle, you just have to squeeze it out. And so if you can just get the just right amount, then you don't have to worry about squeezing out so much. So I just want to get just the right amount. It's a happy little amount right there. Okay, that's probably going to be okay. I am picky with how much solder I get on those pads. Sometimes I don't soak it up well enough. All right, so I need another pair of tweezers. So the hard part is getting this thing to stay in place. So I got my 2 tweezers out, and we literally are doing that microscope surgery because I have to hold this in place. I mean, you saw how it's the size of one of my, you know, lines on my finger. I'm just lining it up like that, getting in the right spot. I'm going to go all the way over here, and I'm just going to tack it in there. And that will be its new little home. Just a happy little trace. So I'm just going to dab a little bit on here. Let's see if I can do this left-handed. I'm not left-handed, so it makes it a little more difficult. I should turn the board, but I'm going to try to hold this in place so it doesn't move while I dab this, because sometimes it'll just grab onto it. Okay, we're good there. So now we have it held in place, and then I'm just going to put solder across that pad. It will attach to the pad that's right behind it, and it will put it all the way across there. And then it'll be a happy little pad. So here's the tricky part. Right as I touch it with the soldering iron, the soldering iron is going to try to steal it. It's going to try to pull it away. So I need to... If it does it, I'm going to get so upset. I'm just warning you right now. I'm just warning you. This is a good description. Boom. Thank you. All right. So I'm going to try to hold this in place and hit it with the soldering iron at the same time without it pulling up. Please don't do it. Please. Gosh. Need more flux. Need more flux. I'm telling you, it's super tricky because it wants to grab it. Okay, we got that side done, and then this side. Yay. Okay. I think we are good. We are good. Now, should I make that look prettier by putting like solder mask on there, guys? What do you think? Should I make it pro, or should I just leave it like that? Should we put up a vote? Yes, vote. Time to vote. If you don't know what solder mask is, that's what all this green stuff is. So you see how every single piece of copper is covered with green? That's a protective layer that protects it. So what I'm proposing in this poll here is, do I cover up this little piece of wire, this little happy little wire, with solder mask to make it look prettier? To make it look, I can't say that saying because it's owned by somebody else, but to make it similar to factory. It's not really owned by him, but he does. He's not very happy when people use it. So I will not use it. Just being very careful here just to clean. If we are going to solder mask this thing, which 69% of you want to see that, then I need to make sure this is very clean so it has something to stick to. Yes, all of this is $249, includes parts, labor, 1-year warranty, and return shipping. Yes. And doesn't pay the bills. Yeah, this, my repair department does not, it's not a money-making endeavor, I can tell you that. But it does pay multiple people's salaries, and there's no complaints there. So that's all we're looking for. It's not a huge profit center. I employ 18 people, and everyone thanks. I thank everyone for their support because they thank you. I need to get all the rest of this flux out of that little area, but I'm trying not to grab or get too much into that area because I don't want to grab it. This is what happens is I start like messing with something. Like right now I could just install the chip and be done with it. But if I start messing in here, then I'm going to end up making it really bad or worse. Come on. I think it might be clean enough to stick. Might be good enough. I'll break off that little wire. I know that you guys are probably looking at this little wire going, you didn't take that wire off of there. So I'm just going to go like this, and it is gone. How are we doing? 73%. We got 673 people in the chat, and we only have 154 votes. I mean, 673 people are watching this. So maybe people are watching on TV and they can't push the button. That's fine. But we should have a higher percentage of that. But I'd say 73% of the people right now want to see some solder mask action. Okay. We're going in. I think it's majority. So we'll end the poll. 26% of the people said, nah, don't bother. It looks good. 73% of the people say, make it look professional. That little wire needs to be professional. So here's another, we're going to plug everything. Northridge Fix is getting plugged tonight. We're just going to do it. So I bought a bunch of stuff back in the day, a while back from him. So these little traces that we just used, Northridge Fix. I don't know if he still has them. I don't know if he still has any of that stuff. This is from Northridge Fix also. This is the solder mask we're about to use. This is from Northridge Fix also, which I don't know if I can pull it this far. Here, we'll hit the overhead camera with it. This is a UV light that's for curing, so we got that from there. So watching his channel, supporting his business, that's what I did by buying this stuff, and that was before his rants. I can tell you that, but anyway. So let's do this. So the way I'm going to do this is I take a little piece of, this is like a thin cloth, or I don't know, what do they call it? It's like a chem pad or something. You don't want to use a paper towel because it soaks into it. So this kind of beads up on top of this. And so I just put like a tiny little drop on there. I mean, I'm talking about like the tiniest little drop. Here, we'll do it on the overhead here. So I just put the pad down like that. Pappy sent me a donation. Thank you so much. Yes, the hot air station I'm using right now is really good. I don't know about that other hot air station. I can't really vouch for that. I've had 2 different hot air stations in my life, and this one by far has been the best one. I've had the heating element go out one time, and I just bought a new heating element. It didn't cost very much, and that was it. So I just put a little dot on there. It's so tiny, so microscopic. And what we're doing is we're just going to take a crappy set of tweezers. I got some old Hackos. And you see the dot is tiny. And so I'm just going to take you can see that I still have some solder mask on here from before. Just a dot like that, just a little dab. Okay, and then I'm going to get this out of the way because it gets all over me if I forget about it. And I'm just dabbing it right on there. And so when I come over here, you thought that I got just a little bit on my tweezer, right? Watch this. Wow, thank you for the $20 donation. Look how big this dot is going to be. I had just the tiniest little dot, but now it's going to get everywhere. I can tell you right now. I just need to get this at the right angle. But that's okay, because we can scrape it off. So we're just going to dab it right here. Boom. See how much it got everywhere? It's huge. It was such a huge dot, and that's only a fraction of what I put on that little cloth. So I'm just going to spread this out just a little bit. I mean, I said I don't even want that much there. That's the thing. It doesn't look pro. Oh, and I don't have green, by the way. All I have is blue. So I'm just going to spread it out so it doesn't look so, whatever, jank. All right, so that's good enough. And now we'll use the UV light. You turn that on, and it cures it. So we're just going to put it on top of there. And it runs for about 20 or 30 seconds at a time. And so what I usually do is I run it for a little bit, and then I'll put 300 degrees C on my hot air station, and I'll start blowing it with that at the same time. So I'm going to run it, and then we're going to go again with a hot air station. And the UV light by itself will actually cure it just fine. But the hot air station will make it cure it all the way through versus you just being on the surface. So I kind of hit it with both. And I'm at 300 degrees C, by the way. So I'm not like doing super high temperature. I'm just kind of blowing it at it. Here, I'm going to do this on the overhead instead, so it's not so unobscured here, obscured. So it's doing that. Turn this back on. Now, it's funny, after all this, we put the chip on there and the machine doesn't turn on. What do you think? Oh, that would be awesome. Then we get to do more stuff. Why cover it instead of just cutting the wire at the end? Well, because I wired it all the way to that capacitor. So here's what I'm thinking. We got a lot of current going through there, right? We have a lot of current going through here. And this pad, it's crooked, but don't fault me for that, right? We're going to be okay. We're going to be okay with that being a little bit crooked. But I have the pad. This is what we added. Oh, I still have some of the other trace on there. Okay, the pad is here. It's soldered to the other pad there, but then this pad still comes over and it's able to connect onto here. So it's just extra current that is able to supply. So it just makes it better. I think it's better. What do you think? Yeah, I think it's better. Yes, I could have just cut the wire off there, not having to do all that. And then you didn't get to see me do solder mask. Okay, so that's muy bueno, mucho bueno. And let's make sure we don't have a short in this area. So we're back to continuity mode. I doubt we're going to have a short, although we could. Fatal last words. Oh, it beeped for a second. That's freaked me out for a second. It's an upgrade. Yes, we're having it. Soren would say we have an upgrade. And you know what's cool is that we actually have brand new chips. Look at this brand new chip. So if anybody's watching Soren's channel, he always is digging through a tub of a bunch of chips that are just sitting in there, and then he pulls out a chip and he's like, oh, look at this brand new chip. So I actually have brand new chips, and that's why I like stocking the stuff that's common that I always have issues with. These go to a lot of different boards, so it is the same number. So let's grab that out of there. And we could just stick it on there, solder it on, and it will probably work, but you're going to have a lot of issues getting this to solder on there. You see all the pads? Because this factory would have a little more solder here, or would have solder on here. I don't know. I never buy a QFM that has solder on it, so I guess it would be on the board. But basically, this is not enough solder to really solder it to this, so what I usually do is I put solder on here. I cannot say that L, guys. Sorry about that. So I'll put solder on here, I'll put solder on there, and then we'll put it together. We'll marry them, and it'll be happy little chip. So we're going to pretend this with solder. Perfectly calibrated wire. Yeah, that's a good saying. I really like that saying right there. I should make him a shirt and send it to him. Yeah, proper calibrated wire, yeah. Proper. However he pronounces it. Pappy again. I'm working on an arcane motherboard and did some repairs, conductive silver paint. Oh, interesting. Should I use a mask over it? It's not required, so the mask is more to protect anything else from shorting across it. So you can have it all exposed if you want. Really, whatever you... That's a pretty cool idea, though. I like that conductive silver paint. So I still have some solder on my tip here. I'm going to clean off the solder that's just been baking on there, and then we'll put some fresh solder on there. An easy pizza shirt would be good, too. But it needs to be like a slice of pizza that's like a laptop that's half open or something, right? Or some sort of design like that. I like designing shirts. It's fun. All right, so what I'm doing is I'm just pre-taining those. I'm just putting a little bit of solder on all these. I'm just going to dab the middle just for a second. Ah, I put too much on there. So I have too much solder in the middle. Yeah, what can you do? I want a little bit more on this pin right here. It's frustrating because I have to hold it with one hand with the tweezers, and then the other hand I have to solder, so it's hard to do it the correct way. The real way you're supposed to solder is you're supposed to put them together and do it, but I can't do that in this orientation, so. I think we might have enough on there. All right, so this is the power management chip. Now that we can get this back on here, we fixed that broken trace or burnt trace. I have my air set up. And Dell's very, very nice. They're very nice people because they have pin 1 located right there with that little dot. We don't have to think about it. And the manufacturer of this chip, this ISIL chip, has pin 1 on here somewhere, but I can't see it, so I'm going to hit it with the hot air for a second, and it will reveal itself. And you can see that the pin 1, I already have it in the right orientation. So we're going to put it in this orientation like that. I need to put a little bit of flux underneath it because flux is your best friend when it comes to doing this. There we go. All right, so I'm just going to preheat the board again. What we're looking for is the solder to get shiny, and then you can tell that it's melted. And I can already see some of the solder getting melted there. There we go, boom, 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 boom. So that's ready to go. Now I can actually come in with the chip. And I'm just going to lightly set it there and move away. It is crooked, but what I want to do is I want to try to get it tacked onto the board just enough. And the tension, tensile, well, what is it? The surface tension of the solder will hold it in place. See how it wants to seat itself by itself? So I'm just going to dab it, get it in the right spot. There we go. And I'm going to move away, let it cool off again. And once it cools off, then I'm going to apply a little bit of pressure. We have too much solder underneath it, so I'm going to apply a little bit of pressure here. We're going to reheat it. It's going to squirt out all the extra. There it is. And I'm going to let it cool off again. There you go. And now we can turn on the board and try it out, right? No. We have to clean up all this extra solder. So I'm just going to hit it with a soldering iron. God, this tip is dirty. And now it's even more dirty. Come on. There we go. This tip is kind of big, but I have a smaller tip, but I always end up having issues with it not getting hot enough at the end. I really should put some more flux. Like I said, flux is your best friend. If solder's not flowing, it's because you don't have enough flux. Not because you suck at soldering. Okay, that's good. All right. Good enough. Will it work? Will it work? Will it work? Let's do a poll. So we will see if this power management chip is the only issue. I mean, it was a pretty big burn, so we could see that that did have catastrophic failure. And now that we got it replaced, we got that new pad put in there, replacing that trace that was burned. And what I'm doing is I'm just trying to pick up all the rest of the flux that was left behind, because I hate dirty boards when people leave the board all dirty. So that's why we're cleaning up after ourselves like a good citizen. All right, so there we go. We have the new chip installed. Now we can quickly assemble it, reassemble and test. Now I could test it on the counter, but then what thrill is that? Because we won't get the screen, but we'll get it to pull some current. So I don't know if you guys want me to do that or not. Because I can plug it in right now and I can see if it starts pulling some current. Sorry, my phone's ringing. Let me mute that there. Okay, I'm just going to put it in the machine real quick. And then we can see if we saved another laptop. It doesn't take very long to install this, luckily. These boards are easy. They come in and out very easily. All right. So I think 87% of you guys have faith in me that I actually fixed this motherboard. I still think that there is a chance that we do have some other issue that is caused by that chip blowing up. Or not, the chip blowing up may have damaged something else, but I don't know. Should work, theoretically. I hope it works. Power button, that's just the fingerprint reader, I think. We don't need the fingerprint reader. Let me put a couple screws in here so it doesn't fall out when I flip it over. %, 85%. Oh, I think there's some doubt coming in there because I said that. Maybe I shouldn't have given you a little biased opinion. You should stick with having faith in me. Should I put a battery on it? Here, should I put his battery on it? Maybe his battery blew it out. Yeah. These aftermarket batteries, whew, they are something else. And I don't know if you've seen this on aftermarket batteries, but take a look at this. It has a picture of fire on it, but they have an X on it. It says, don't light it on fire. But it burned out this board. Yeah, so we'll do it with no battery for right now, and then we'll put our battery in, my test battery, and then we'll continue, right? Okay, so I have it in there. I have a couple screws in there. All the stuff's plugged in. We are going to go with the barrel jack, which is just a regular charge jack on here. And everyone has faith in me. So keep an eye on the power meter. And we got 0. What does that mean? Power it on. We got 0. That is strange. But it's not as strange as you think, actually. So what we talked about earlier is that the CMOS battery is plugged in the board right now, and it was at 2.6 volts. If the CMOS battery is at 3.0 right now, then I'd be like, oh yeah, there's something else wrong. But there's a chance that the CMOS battery, because we had it just sitting in the board just being low, it might have even went lower and lower and lower, and it might be in that in-between voltage that won't allow the thing to turn on. So, but technically, 15% of you guys were correct. But I think we can get it going. I need to unplug the CMOS battery real quick, and that way we can do a CMOS reset on it. The machine should have turned on automatically, but it didn't because we didn't have the CMOS cleared. There we go. CMOS battery is located right here. We're just going to unplug that, get that guy out of the picture. You are out of our picture. So now the machine, when we won't even need to hit the power button. Right when we plug it in, the thing will power on. Anything below 2.8 is pretty much trash. Yes, it was at 2.6, so it was right on the edge. However, I have bought a bunch of brand new cells before that were all at 2.6, and they charge up because they are rechargeable. So they charge up. So I don't know if that's the case, you know, or why they start out so low. It's pretty strange. Okay, so it should power on by itself. I'm still going to put these screws in here so it doesn't fall out. Let out the magic smoke. Well, we didn't let out magic smoke on that first attempt, but we could still let out the magic smoke. All right, here we go. Will it work? Number 2. Okay, keep an eye on the power meter. Plugging it in. Nothing. Nothing. How is that possible? How is that possible? We had so much faith. You had faith in me. I had faith in me, kind of. We're going to do USB-C now. Let me put that meter up there. Still nothing. So there's more. But wait, there's more. So we do have more of an issue than we thought, and that's what I was thinking. There was a possibility of that at least, because we had a big explosion there, and that does end up pushing something more. I don't think our wire's messed up or anything. I'm pretty sure we're getting 19 volts there. So now, from now on, we're not going to put it back together. We're going to be testing it on the bench, and we will be able to figure out what's going on. So again, because I unplugged the CMOS battery, the machine should have turned on automatically. And because I just tested it with the barrel jack and the USB-C, then we know that it's not just the barrel jack being the issue. We know that there's something in the entire charge system. And let's go back and take a look at my solder job. Maybe we have a really shoddy, dodgy solder job. So I'm going to just put it on the side here. I'm going to go up a little higher with my microscope here. See if that's high enough. Sometimes I don't do a good job soldering. Look at that, it's crooked. There's a couple pads right there that don't look like they have really good contact. This is what you call performing on demand issues. So I'm just going to reflow it just in case. Let's look at this side. Yeah, look at that. Well, I don't know, maybe it's not that bad. I mean, all of those pins are touching. They could be touching better. So that's the problem I'm talking about. Like whenever you get a brand new chip and you reflow it and you tin the pads and then you have to tin the pads on the board, sometimes it just doesn't get enough solder, you know? Thermal camera's not going to do anything, guys. If it's not pulling any current, there's not going to get hot. So there's nothing to get hot. Yeah, and that pin right there on the end doesn't even look like it's touching that well. So I'm going to reflow this real quick. We'll just start with that. What I like to show people, and you can see it's even a little crooked. What I like to show people, even somebody who's been soldering, I've been soldering since I was 11 years old, okay? Even somebody who's been doing this a long time will still have issues and stuff happens. And so it's real, right? This is a real repair. I solder sometimes 8 hours a day. And so this is, you know, just a fact of life. It's not a big deal, right? And we don't know if that's the issue anyway, but what I'm going to do is I'm going to just reflow it and see if that does fix it. And sometimes that final push of solder out the sides and the bottom sometimes it doesn't allow it to sit all the way. So now it's kind of suction cup to it. That's what I don't like when it does this. So let me just pull it off real quick. Okay. And I'm going to add a little bit more solder to those pads, and then we're going to come back. Don't use flathead soldering tip. Yeah, I don't generally use a flathead soldering tip. Mine's a hook. It's still kind of big, but... So the one I'm using is this little hook one. I have one that's a little more fine tip, but when I do that, it's hard to get enough heat to the board. So all I'm trying to do is just get enough solder across here. I don't want to get any more in the middle. And I don't want to mess up our beautiful solder pad. No! Did we touch it? Did we move it? Get back in your home. Okay. Now, once I put this back on, there's a chance there's something else going on. So we just want to eliminate this as being a possibility. So we have the orientation correct, right? So pin 1, pin 1. So pin 1, pin 1. And we are going to reflow that back on there. And then we are going to test around it after I plug it in, if it doesn't turn on. Okay. It's hot. Got it there. So the thing is that because the center doesn't have a lot of solder, then it's not floating on that. So it's hard to get the seat in the right spot. So we're just going to try to make sure we get it in the right spot. Because otherwise it should just kind of like you can knock it and it will move back. You see how it wants to kind of suction in that spot where it is? So we're just going to try to get it lined up the best we can. Apply a little bit of pressure. Ah, I bumped it. There we go. Okay, I think that's good. Steady. Oh, perfect. I think it's perfect. It looks a little more symmetrical. Look, it's off to the side still. It's hard to get it from that angle. It really doesn't matter that much, but it does matter on these side pins, so I do want to move it that way a little bit. It's funny, from that angle we were at, it looked like it was symmetrical. So we're going to move it one more time. I do like it whenever Dell puts the little lines on the board, and then I know how far to move it over. So that's probably what's messing with me right now. Or it's been a long day. One of the two. There we go. Okay, that's symmetrical. All the pins should be good. We have perfect pressure. You want to change the vote? Should we do another vote? Oh my gosh. Okay. Yeah, I didn't have much solder underneath this chip. I had it a lot the first time, and so now there's not much. And that's why it doesn't want to move. That's why it doesn't float. Normally you can get it to kind of just go back to where it was, or you can get the seat, but whenever it's really doesn't have much in there, it kind of suction cups to it, and you have to push it in the right spot. Thorough cleaning. Should I do my thorough cleaning? If I don't do thorough cleaning right away, then I always forget to do it, and you have to heat the board back up because it needs to be warm. Okay, so I'm just going to plug it in right here. We have our USB-C power meter there. I'm going to plug it in, see if it starts pulling current. And it's just sitting there doing nothing still. And we had a 50-50 vote. I know I didn't give you all much time to vote. 138 votes said it was dead on 50-50, and it's not working. So now it's time to measure. Now it's time to figure out why. So I'm in voltage mode on the voltmeter. We're going to make sure we have our 20 volts coming here, which we are. 20 volts coming all the way to this pin. Are we getting it on that pin? We are getting it on that pin. I cannot remember. I don't have the schematics for this chip. So I'm trying to remember what pins are supposed to do what. I'm used to the ones on the newer machines, but let's see. I don't know which one's VDD on here. 3.6 means that's AC detect, so that's there. And I believe that this should be VDD. Yep, so that's there. So VDD is the powers the chip on. So the chip's getting power. It's detecting that the AC adapter is plugged in. That's what that other one is. And the next one is nothing. The one after that is nothing. The one after that is nothing. Nothing, nothing. Why are we getting nothing all the way across there? We should be getting something across all of those. Should be getting 3.3 is what I think. That's a strange one. And so what are we getting over here? We have 20 volts there. I need to pull up the schematic for this. Read JFix's comment. Oh, thanks JFix. So I got to go find you here. The diode not flat on the board, but looks correct. Okay, let's see. Yeah, it is. It is a little crooked, but why is it crooked? That's the question, right? It's fine. Measuring fine, it's connected fine. It's just a little crooked. I don't know why it would be like that. Do we have a burnt resistor? A feedback resistor or something? Because we are getting the voltages we need over here. We probably have another burnt component somewhere else. That's what that means. The new pad's fine. Did everyone get that measurement? So the pad comes all the way over to here, 20 volts. Wait. Oh, I'm not plugged in anymore. I was like, wait a minute. 20 volts right there. So we are getting our 20 volts all the way across. And the chip is powered. It has its 5 volts. It has its 3.6, which is the AC detect, or the ACN detect. I can't remember what they call that pin. Ask AI. They will tell us so much useful information that's regurgitated from something else that was regurgitated from AI. I love it. Is that chip from eBay? No, these are brand new chips that I ordered from Mouser. And I've used them plenty of times, so these don't need to be programmed either, so it's not one of those types of situations. The voltage driver on the gates, yeah, I'm thinking that it actually is giving... I just want to look, we need to do a physical inspection on the board, because if we had a blown component there, let's just do a physical inspection real quick. Because I want to see if there's anything else that we missed, right? And we didn't do that besides just look at the power management chip. So let's go through here real quick. And we know the board's working everywhere else on that other side. I mean, those MOSFETs look crazy. Look at all that stuff coming out of them. Should we check to see if those are shorted? So the way these MOSFETs are supposed to work, you know, they're supposed to act as a switch, but we're measuring a short from gate to drain. So there is a possibility that this chip is shorted. You could sit there and say, yes, it's shorted, but I can't say that because the state that whatever's actually, the power management chip could be putting it in that state. So, but yeah, I do see a lot of flux or whatever it is coming out of all of these. So there's definitely been some heat over here. And what about this one? Yep. This one's good. And that one's good. So I think this one's our bad guy. So yeah, let's check to see what we got. If this is shorted to here, and it's not shorted across there, let's see what we're getting, what voltage we're getting on the gate pin whenever we plug it in. We're getting flat 0, like nothing 0, 0. And we have 20 on this side, right? Yeah, let's change this guy out. It's a 6380. Let me grab a 6380. You want to do voltage injection? You guys love this thermal camera thing, huh? Yeah, we can do voltage injection, but you know, we're finding a short, so we found the short. I mean, most likely. I mean, it could be the power management chip, but all we have to do is pull this chip off, and then we can just measure to see if the gate is shorted, and then on the chip, and then we'll figure it out. Done. So I don't need to do voltage injection. Let's just pull it off real quick. So my soldering job was fine, right? Short circuit MOSFET detection, yes, it probably is. It's probably detecting it, and so it's shutting off, the power management chip's shutting it off. Correct. From the ISL chip, which is the power management chip. And yet we didn't finish our physical inspection, by the way. We stopped right here. We keep getting like, oh, here's something. But I kind of feel like this is probably it. So look at that solder just bubbling out of there. All right, let me show you how to test this, by the way. So does everyone know how to test the MOSFET? So let me grab a good one, and then I'll show you a bad one. Okay, so here's a good MOSFET. Oh wait, that's a dual MOSFET. Hold on, let me find a single. There we go, here's our single, okay? So to test one of these, if you're trying to figure out if one works, we're gonna put it in diode mode on our meter. And if we measure from one side to the other, we should actually get a voltage drop across it, okay? Now the moment that I flip the chip away, hold on. So these three, those are the drains. And so the voltage comes in here, comes out these three, and then this is the gate pin that turns on and off. So right now we're getting a voltage drop across here. The moment that I touch this pin, this will be on. So now this is measuring shorted. So now if you tried to measure this, you'd be like, oh man, this thing's shorted. Hey Corey, thanks for the donation. You have a laptop there for a repair right now? All right, so we might go grab it. We have another contestant. So right now this is showing shorted, right? And it's because I touched my positive probe over here. So now if I flip my probes and touch this and then flip it back, this is turned off again and measuring just fine. And so if I measure one way, I'll get a voltage drop. If I measure the other way, I won't get a voltage drop. That's how it should be. So that's a properly working MOSFET. So let me grab our MOSFET that we just pulled off the board, and let's figure out if this one's good. Yeah, Corey, what's wrong with your laptop? Don't tell me it's like a screen replacement, because I won't do that. I refuse. All right, so we're going to measure the output, and you see that we're getting a voltage drop here? And if I touch there, it's turning on, right? So now it's shorted across here. But if I flip my probes, touch here, it's fine. So this MOSFET's fine. So that means that the gate and drain are shorted on the board. And why would that be? So this is what always tricks you, you know. And see, look, it's showing it's not shorted now. It's like it was actually enabled. Okay, so if I go that way, it's showing shorted. Interesting. If I go the other way, it's not shorted. So do we have a diode that's messed up somewhere? What do you think about that? It's not shorted to ground. When I use the word short, you know, we're not talking about shorted to ground. So, I mean, I guess I can check if it's shorted to ground. Neither one of these things are shorted to ground. Okay, so a short to ground is not happening. A short across here. So why are we getting 0.07 voltage drop? And if we go the other way, we're getting a regular. Oh, we must have a diode messed up somewhere. You guys want voltage injection. I don't even know how I would use voltage injection to do this. we could change out the power management chip all over again. No, I don't know what is going on. Do we have a double diode that's messed up somewhere? I don't have a schematic for this. Oh. Here's the board part number if you guys can find it. Let's see. It's an LA G41P. G41P. That is strange. So I'm wondering if we just jump right across. No, because that actually has to reduce the voltage. So we can't just do the jump. This is interesting. Let me replace this MOSFET anyway, just because we have it off. And we'll put it back on and see what happens. But I doubt that that's what the issue is. Hang on, go back to Q1901. Is 1901 on the back? That's 1900. Where's 1901? I didn't check 1901. It might be one of these even, because I know that the voltage comes through here too. So we could have one of these that are bad, and it is detecting a short, so it's shutting off. Remember, this one has that's extra solder there. I knew this one wasn't going to be easy. Oh, finish board inspection. Yeah, well, let's do that. Okay, so we stopped over here because these looked all sketchy and they had all this extra juice or whatever coming out of them. But they all checked out. They're not showing shorted. So all that's fine. I don't know why we have all that flux coming out of there, but we're going to keep looking. And again, if I go too far over here, it doesn't really matter because the board is turning on. There's the BIOS chip. There's the PCH chipset. So it's not going to be anything past there. And this is really the only other area. Look, I need to clean up my mess here. Let me take this, there's an audio board here. I might be able to see something underneath there. No problems, just solutions. Okay, so I took the audio board off so we can look underneath it. Yeah, I feel like we're going to have another burnt chip somewhere. So I know over here's the PSID. The PSID chip is burnt. Look at that. You guys see that? So this is what I was talking about on this machine, that this 33 ohm resistor will burn out. Can y'all see the dot on it? Can everyone see it? See that little circle? It's like a little eye. So this is a 33 ohm resistor that ties to the PSID pin, which is that communication pin on the DC jack. And that allows it to communicate so it knows what type of charger it is. And otherwise it won't charge or won't run at full speed. So we can change that out to fix that, but that won't prevent the board from coming on. It should still work with the USB-C. Unless, I mean, you know what'd be funny is that, what if the USB-C port doesn't work? Or like maybe it's been busted for a while. Maybe I should try it in different orientations. Although we just took that MOSFET off of there, I just want to see what it does. It's communicating, it's going up to 20 volts on that way. Let me flip it over. And same. And it is pulling, the 20 volts is getting there, so it's not that. So it should power off the USB-C port. So let me just change that out real quick just because we're right here. It's not going to fix anything, but I guess it'll fix the charging when we get to that. Anything else that you guys are magic smoke? Okay, resistors, where are you at? Always do your physical inspection. I know, I keep getting sidetracked. But we keep finding stuff. So I guess we're doing what we're supposed to do. Look at that little burn hole. You see a copper wire dangling. Ah, just gonna dump a bunch of those down there. Okay, so this is a 33 ohm resistor. Thank you so much for that donation. Look, I'm not even putting flux on here. We'll see what it does. See if it actually sticks. See how I tacked it there and then moved away, and then now I'm coming back to do the final heat on it. So there you go, but it's not really sticking that well on that side. You see that? So we're gonna add le flux and everything will work much better. There we go. You see how it sucked it right on there? Okay, so that's fixed. We'll keep looking around the board. Put the MOSFET back and inject on the current sense resistor, but I mean, I guess I can just put 20 volts on the current sense resistor. Because I mean, again, if it's not shorted to anything, it's not like anything's going to get hot. But you know, we can jump voltage straight to it if we want to do that. Let's keep looking here. That's just from me, right? All this stuff is from me. We'll do the whole board just in case. I have to keep checking chat in case you guys are giving me some good advice. Dusty, that's the EC chip. Here's that CMOS battery. Okay, I'm going to grab a new DC jack, and then we're just going to plug it straight into it. Let me go grab one of those. That way we're not using his DC jack, we're using one of mine. And then we will plug in the battery, see if it starts charging or doing something different. All right, I think this is the one right here. All right, let's switch back to the other power meter. I need to put the MOSFET back on. Yeah, let's put the MOSFET back on. But I wanted to replace it with a different one. I was just going to grab a donor board. This whole stack is the same board. So I have tons of them. But let me get one that is, this is the newer version, 7997. This is an older machine. I mean, what year was this? Did we ever look at what year it was? 2018. It's a 2018 machine. And yeah, I have some MOSFETs right here. Make sure it's the same number. Yeah, 6380s. Let's make sure. I bet this one's going to measure shorted too. What's funny is, you know, you think that because it's measuring shorted, it's not measuring shorted. Look at that. What if our power management chip's messed up that we put on there? What do you think? What do you think the odds are that we installed a chip that's faulty or we messed it up or something? I don't know. That would be funny. I have plenty of donor boards, so we could just pull one off another board too. So let me pull this chip off. We're going to put it on there, and then we can continue. Dodgy. So dodgy. I'm going to prep this area real quick. Real quick. Oh, do I still have the vote going here? I didn't realize that. You guys are still voting it's going to work? I'm going to stop it because it's not working. We need someone to update our comment at the top, though, that says what is going on now. Our pinned comment. Make it witty. Sorry, wrong camera. So I just put some fresh solder on here, and then now we're going to pull the chip off the other one. Replace every chip on the board twice. Well, you remember we're measuring that. Here, actually, when I pull this chip off, I want to measure. You remember when we measured gate to drain in diode mode? We're getting it where it was showing shorted one way and then not shorted the other way. That's kind of what I want to figure out if this board's doing this too. So this is our donor board. I don't even know what's wrong with this board, though. It's the problem with working on things like this. So we're getting nothing on this, and it's probably because this machine doesn't have a power management chip. Oh, gosh. Okay. Well, that's useless measuring that. Let's reinstall this. After this MOSFET replacement, it might work. You might be right. So which way does it go? So there's a pin 1 here, but there's no pin 1 on the board. There's kind of a dark area here, or there's a little line, so that is our pin 1. And on MOSFETs, it's easier to see because you can just look at the bottom. You see how it has a big plate, and so that's what you line it up with right there. I don't know if you guys like all that information. Movie quote. Suppliers a 30 weight ball bearing. What? Thank you, Daniel. It's all ball bearings these days. Love it. Oh. Did you just see that? I've never done that in my whole life. Did you guys just see that? I'm going to hold it in the right angle. The freaking thing just popped. I overheated the chip. That's crazy. That is crazy. Okay, well, we'll grab another one. So basically what I did is I normally will heat the board, and I'm kind of like looking at chat, and so I was keeping this in front of the hot air station, and it just overheated the chip, and then the thing went pop and cracked. That's cray. That's cray, yeah. Anyway, first time for anything like that. Where's that crappy donor board? Or maybe it was a faulty chip. I think it was the technician. Here's another one right here, 6380. You guys like it when I change out chips anyway. You always want me to solder. Yep, user error for sure. Yeah, so I have a lot of heat. I have 450 on this right now, but the board's syncing up most of it, so it's not even like it's getting to 450 in this area. We're only just trying to get it above the melting point of solder, which is like 220 on this board. But when I held the chip in mid-air in front of the hot air station, then it actually hit the 450 and kaboom, kaplow. All right, so we have our brand new chip, brand new. Goes like so. We are going to focus and not get distracted. Yeah. I think I need a water break is what I need. All right, so you see the solder's melting. Now I'm going to come in with it. There we go. Move away for a second. I'm going to add a little more flux to it. It's a little bit floating right now. And that way we can get it to set down. There we go. There's actually a bunch of solder underneath there. I'm going to get it out of there. Boom. Look at that big old ball that just came out. Okay. Oh, I hope this works. I'm getting tired of this board already. How long have we been working on it? An hour and 55 minutes. That's too long. That's too long. And we have somebody in chat that says they have a motherboard or a laptop here. Did we ever figure out what was wrong with his? Corey, what's wrong with yours? Did they say it was a spill or something? Yeah, time to move on, or time to make a vote to move on. Well, it'd be better if I could fix this on demand. Kit Kat break, yeah. I need some food, probably. Okay. Just a happy little MOSFET. All right, that's installed. Let's plug in the power. It's funny because before with the old one, we would get 0.01. I mean, we're getting no tango nada. I'm going to plug in both. I'm putting both power sources in at the same time. I'm crazy. Yeah, so I'm thinking I want to change that power management chip out one more time. Corey says keyboard's not working. That sounds like a blast. Oh, is it the X17R1? I was going to work on that maybe. Is it your X17R1, Corey? Because there's an X17R1 that has this issue where the keyboard won't work in Windows, or in Windows, but outside of Windows it will. And okay, cool. So let's grab Corey's. Well, we'll do a vote actually, because this is a democracy. Okay, so the gist of it is there is a issue that I've diagnosed and figured out a fix for that is happening to Alienware. It's actually happening to quite a few different higher-end gaming machines that have RGB keyboards. But the gist of it is that the keyboard doesn't work in Windows, but it works outside of Windows. It will work in the BIOS. But when you get the Windows, you'll get a unknown USB descriptor. inside Windows, and there is a issue on the USB data line, but basically the keyboard acts as a USB keyboard, and because it has to control, I think it's a MCU, it has to control the RGB backlight and all that stuff, so it actually is just a USB-C keyboard, or USB keyboard. And so when it's outside of Windows, it's acting more in the USB 2.0, I think, and maybe it's 3.0. I don't know why it doesn't work in Windows, but it doesn't work in Linux either, by the way. So I know that people are like, well, why don't you just use it in that? So, but I figured out a fix for it, and so now I put a video out to show you how to do it. We can do one live. It's not that hard to do, and so we should be able to fix it in a few minutes, hopefully. I mean, there's soldering involved, but... and so to tell you what I'm going to do next on this one, if we proceed, is I'm going to change that power management chip out again. For some reason, I'm thinking there's something wrong with that, because it is acting weird. And I may even just take one from a donor board, because you're making me doubt myself when you said, did you buy those those power management chips from eBay? I definitely didn't buy them from eBay, but I'm trying to think if like Mouser had them, because they may have been out, and I might have had to order them from like AliExpress or something, and which is the same as ordering from eBay, which means they could be just fake chips. And I'm trying to think if I've ever used one and it worked, because usually like all the rest of them I get from Mouser, and they work just fine. So did the MOSFET get bridged still? Yeah, let's check that while we're waiting for our poll. So we're at 62% of the people want us to switch to the next one. I'm sure there's a good percentage of people that would like to see me actually successfully fix something, because otherwise I'm a fraud. Otherwise, I'm a fraud. Let's measure across here. So it's saying 0 shorted. 0 that way. And if I come this way, 0 that way. And you remember when we had the chip off, look at the soldering job. Look at all this solder coming out. I didn't clean all that up. It doesn't matter. All these pins are together, so don't give me a hard time. But basically, this is showing shorted across there. Oh gosh, camera. Sorry guys. These 4 pins are tied together, so don't worry about that solder. But these 3 are together, and then we have a gate pin. We're showing shorted across this. And it doesn't matter which direction we do it. I'm in diode mode, by the way. And so when we had the chip off of there, the chip was measuring fine. When we have it on there, and then those pads were measuring, I don't know. That's why I'm thinking it's a power management chip still, because that's what it ties straight to. I appreciate you. I was just being facetious about the fraud thing. I know. It's just, I'm performing on demand, so sometimes things don't always go as planned, and that's fine. That's why I'm doing real repairs. This is one of those things that's like, most people would not try to do this because they're scared of failure. And the thing is that failure is part of life, right? The only way to learn is to fail, right? So if this isn't working, I'm missing something. And sometimes I'm just going down a rabbit hole. Maybe that chip exploded and it probably blew out something that I'm just not noticing. So we don't know. You want me to change that PD1900? Because the thing is, I could probably just inject the voltage there and it would work. You know what I mean? So it's like, why are those not turning on is the question. So we're at 59%. So it's really close, guys. Really close to switching to this other laptop. Now, what we're going to be, let me show you the component that is bad on those X17R1s. I have it right here because I actually keep them off to the side, and I can give you the part number for it. But it's a choke. All it is it's a filter for the data lines, the differential data lines for the USB, and they are super tiny. So there's the choke. There's my finger. And so we just got to change that guy out and everything will be fixed. So it's quick and easy. We can always come back to this one too if we wanted to switch, but looks like it's going down. Most people are wanting me to finish this one. So let's let that run for a little bit longer. And while we're doing that, I'm just going to grab another power management chip because I don't want to just jump the gun and switch over to the other one. Capiche? Fair? Have you made a video on this one before? So the X17R1 I have a video on. PD1900 is misaligned. 1900's on the back, right? PD19, oh, PD. You're talking a diode, right? Yeah, it's this one. Yeah, we already looked at that with JFix, but it's misaligned, but we tested it, it's fine. I keep switching cameras. Okay, sorry about that. So yeah, it looks okay. It's just crooked. I mean, we can straighten it out if we want. And we tested them too in diode mode. That's the main thing, is like, do they work? Are they connected, right? So if we're measuring here, they're measuring fine. That way, forward voltage, reverse voltage, or this is reverse voltage, forward voltage, the other way around. 55%, 830 people watching, and we have 194 votes. So what? I don't know what to do. Wait, R1 is blown out, is it? No, because we measured all the way across it. And this is, I think, flux or something. So R1, the voltage is coming through here. This is the 19 volts. Comes across here, goes through there. We measured it all the way up to that pin. So we verified that is that burnt or blown? Or is that from me just applying pressure? I don't know. That looks suspicious. But we did measure that we have 19 volts coming to this pin. We have 5 volts coming to the VDD. We have 3.6 volts coming there, which is the AC detect. So it can tell that the AC adapter is plugged in. So it says, okay, turn on. So thermal camera time. I don't know what I could put a thermal camera on. I mean, there's no voltage. You guys kind of understand what, like, you have to have current. Like, I'm going to plug this in again. How much current is being pulled into the board? 0. So that's not going to do anything by plugging it in. And then, I mean, I can inject voltage in certain areas, but it's not going to, I mean, there's no resistance here. So if I measure here on the 19, we are getting 19 here, so that's not an issue, right? This pin's shorted. I think it's supposed to be ground, though. Does anyone have a diagram of this? JFix, do you have it? I shared a schematic and board view. You did? Okay. Let me see if I can get that pulled up. Give me a second. Uh, 341. You shared it on Discord, probably. Let me go pull that up. Thank you, JFix. Okay, so now I can get those put into the right folder, and then I'll open them up for you guys. I did get them downloaded. Schematics. Okay, so now I can open it. I got an error. JFix? That's weird. It's not opening properly in my Flex board view. Error opening file, board view format is unable to be decoded. Huh. I know I got something close, so let me see if I can find the close one. Like a 5500, let's see, 5530, nope, 5520, it's gonna be really close. Nope, don't have that either. What about a 9560? I have a 9560, 9570, 9570. So this is an F541P, which is a little bit different. All right, so we can see this. So I want to make sure that we're good. All right, so we have our board view and schematic pulled up. And where are we looking? So this is the gate pin. This is that MOSFET that we switched out. And these tie straight over this coil. This one is the gate pin, and it goes all the way over here. Oh, and it's paired with this one. Dude. Dude. I didn't know they run in parallel. Huh. Okay. All right. Well, that helped a lot, actually. So what's happening? Remember we were detecting that there was a short, but we pulled that MOSFET off and it wasn't shorted? This MOSFET's shorted then. So this guy, and look, there's some solder ball coming out the side here. So that means that this guy must be shorted because they're actually in parallel. Yeah. So let's pull this one off. It's the same number, right? Yeah, it's a 6380. Okay, well that's helpful. See, that's why board views are awesome. They tell you where everything goes. So, yeah, PQ 1900 and 1902 are in parallel because the gate pins are tied together. Yeah, it's a there's no short across the, it's in the drain, yeah, so I'm going to pull that off. It just flew off. All right, let's see if the short's gone now. Should be gone. Should be gone. Look at that. We don't have any short there. No short there. And if we go back to our El Chipo over here. Nothing. I'm getting nothing across there. Which is, should be correct, I hope. Yep. Okay, should turn on now, guys. Thank you, JFix. So yes, I haven't put it back on, but it should turn on because they're in parallel, so they're both working together. And still nothing. No. Oh my gosh, still nothing. You're killing me, Smalls. You're killing me. Do you think that it blew out the power management chip because it was shorted and it tried to turn on whenever it did it before? This is the USB-C's plugged in, doing the exact same thing. Yeah, let's go back and look at this real quick. So, if you look at how this is set up, it actually has them in parallel, right? So there's two of them, right? 1902 and 1900, right? So we have our 20 volts coming in down here and comes across both of them. through the 3 pins, and then we have our gate pin, and that ties to the ISL chip, which is over here. And we tested that both of those were tied together. So we have it going to this pin, is the gate pin of this chip, but it's also the gate pin of the other MOSFET on the other side of the board over here, right? And it got rid of it. I'm thinking that we should just, I don't think this needs to be on there for it to work. What do we got here too? A resistor. And we're not having a short on that because the 19 volts, I think, or this is the, yeah, we're getting our 19 volts here, I think. Let's measure there real quick, actually. Oh, we are getting our 19 volts because we measured that, I remember. But we can do it again. Oh yeah, it doesn't even have that populated there. I'm just trying to go by memory at this point, what we already tested, but we should have 19 volts here. Or is it 19 volts on this side? 19 volts is on this side, and then this is the output, that's right. Oh, it's getting late. So this side we should have our 13.6, which is the modulated voltage where it's trying to reduce the 20 volts down. So, I'm thinking this. I'm thinking that. Do you agree with me? I think it's going to have to be that power management chip. Yeah, 2 chips, they're in parallel. Change the PMC. Yeah, PMIC. Let's do it. Takes 2 seconds. Let's do it. We should do it while it's still plugged in. Have you ever accidentally changed out a power management chip while it was still plugged in? Yes is the answer. I've done that before. Because I'm like sitting here testing stuff and I plug it in, test it, plug it in, test it, and then I forget to unplug it. It's 8:15 here, p.m., and I tried to come and work a little bit late today, so I think I got here at like 8:30 or 9, 8:30 maybe. So yeah, it's coming up on 12 hours being here. Miller time, yep. I'm gonna have me a bourbon when I get home. Probably an old fashioned of some sort. All right. We'll put that one there. So we did resolve that short issue that we were having. So we should test that MOSFET that we pulled off. Because remember we were just like, oh yeah, it has to be shorted. And that will at least make me feel better about this. 13.5 is the volts, okay. Yeah, I was thinking it's 13.6, but yeah, 13.5 might be right. All right, so we're gonna measure from here to here. I'm getting nothing. It's weird. Okay, so we have a short because I touched there. And then if I flip it and touch here, it should turn it back off. And the MOSFET is good. Oh my gosh. I don't know. Yeah, I'm just changing. We're going to change out the power management chip anyway, but this is crazy. This is crazy, man. I'm about to go into autopilot and I'll have JFix tell me what to do from here on out. Because I'm tired. Oh my gosh. I'm going to add a little bit of soda in the middle, just a little bit, because it's just a little bit drier than I want it to be in the middle. Yeah, we can switch to Corey's. I still have that poll up there, so I mean, I don't know if we can switch votes at this point, but 55% of the people still want me to keep working on this crazy mess. And I would love to just make it work. But why did it blow up anyway? Think about that. There had to have been a lot of current that bunched up right there on that. Yeah, JFix is going to get some new subs. Yeah, he's a balla. JFix is a balla. What should I do? Should we grab a power management chip off of another board, or should we grab one out of that brand new stack that didn't work on this one? I kind of feel like I want to pull one off a board. Pull time. Yes, old board. Yep. The votes are coming in 100%. Yeah, I like that. I like it when it's 100%. Oh, someone's broke it down to 96%. Let's find one. Let's find a donor board that has something that is not like, you know, like here you go. This one right here overheats. It has some sort of heat issue, which means that if we plugged it in right now, it should turn on. So let me just show you how it's supposed to work. I got my USB-C, I look at the meter, I plug it in, 20 volts, and then it's at 0.02, and it should start pulling current. Why aren't you doing it? So this is not a good candidate then. Weird. Well, I would say that one's not even turning on. What's this one say? Has chicken scratch. One of my techs put chicken scratch on it. I can't read chicken scratch. What's going on? This one's doing the same thing. Let's put a barrel jack on it. Same thing, 0.02, 0.03. Now, I mean, I can hit the power button, but it should turn on by itself. So to me, it doesn't make sense that it's not turning on by itself. Well, I just switched to another power supply, so it can't be my power supply because this is just a regular Dell charger that's in my power meter, and then this is another Dell power supply that's through there. Let me just grab it. These are all bad board. I mean, they're donor boards, so. This one says no power. This one says needs a BMS. It needs a power management chip. Oh. Let's see. No power again. Here's a 3.5. A 3.5 would actually work pretty good. 3.5 is a power rail? No, 3.5 might be a BIOS on this one. So let's plug it in and see if it starts powering on. Oh my gosh, this is weird. This is weird. Let me grab another one. Okay, this one should actually power on. Yeah, maybe I should reset my charger. Because, I mean, every single one of these is doing the exact same thing. That's crazy. I mean, it is a common fault, the power management chip. This one's a no post. All power rails are good. Hey, we got something pulling some current. Okay, so now it's powering on. Yeah, all the equipment I'm using is not just power supplies. So this meter right here that I'm using on USB-C is a real Dell 130 watt charger. My actual power box on the side is a real Dell 240 watt charger that plugs into the back. So everything is legit. I'm going to try my DC jack on this one also. Make sure they both work. And it's pulling current also. So, all right, we got a good power management chip. Hooray! Hip, hip, hooray. But this board, what was the error? All rails are good, but something not posting. Okay. So let's pull this one off. I hope you're learning on this channel, learning to fail. No, eventually you get it. It's you know, nothing straightforward. You know, not all repairs are like super easy, except if we were, oh, look at this, this is using a BQ chip. Ah, you're killing me here. This is not the same board. The boards look identical, by the way, just to show you. You see that? Same board looking, same board layout pretty much. But this is a, this is the board part number that we're working on, and then this is the board part number for this one, which is an older generation. Sorry, guys. Sorry. So it's using a different power management chip. It's using a BQ chip. Yeah. Dell, I mean, it's kind of a, you know, they kept the design the same, but then they redesigned different things for more power or whatever it is. So I'll find one. Put some faith in me. I got so many of these boards. Well, at least we know the charger's working, right? Yeah, should we do the Corey vote again? Are we getting bored with this? Oh! Whoa, that hurt. Did anyone see what the power meter got up to right when I plugged it in? It hit 3.3 amps instantaneously, and my finger was on the CPU. And so I think I have a second-degree burns on it. I think somebody a couple weeks ago was like, never put your finger on the CPU, and yeah. But usually it just kind of comes up. But that's 3.3 amps of pure heat. That did not feel good. But I put my finger on the CPU so that I know if it's booting up or not. I'm also looking at the current, but boring. This is starting to get boring. Someone's going to start chanting, Corey, Corey, Corey. Yeah, all of these are missing power management chips. All of these other ones that already have parts missing off of. That's why I'm trying to find one that has it on there. So 361 again. So this is the older style. This is the newer style. This one says it has no service tag, processor, something. Okay. All right, went to 1 amp for a second, went back down, it should come back up. There we go, it's coming on. Okay. Now, do we have the right one this time? A spicy meatball. Okay. There it is, 88738H. So, if we want to, we can look at voltages real quick on this chip before we take it off, right? So that way we can kind of get our head wrapped around what's going on around this chip. It's always good to be able to compare. And I know that, I think somebody put some of the voltages in there, which is helpful too. We're not going to leave it on for too long because it doesn't have a heatsink on it, but. All right, so here's our big ground plane. This is our 19 volts, right? So we're going to plug it in. We can see 19 volts there. You see 5 volts there, 5.2. This should be 3.6, right? And then the next one is 0. The next one is 0. The next one 3.4, we're missing 3.4 and 3.3. What do those pins do right here? These last two is the question. Which direction are we? So it's these two. What are these pins doing? It says it's not found in the schematic, which is so awesome. So VDDP has a cap on it. And then this goes to an L gate. Huh. Okay. Wait, that's not the right pins. Sorry. It's proc shot and a COK. So we're missing these two, I think, when we had it on there. So are we not getting this feedback? Is this resistor blown right here? And where's that resistor located? I want to make sure I'm not turned around. So pin 1's here. We're measuring here. Yeah, so we're measuring there, and those are the ones we're missing. Pin 1's here. We're measuring here. Sometimes I get turned around when the schematic's backwards, by the way. So here's pin 1. This is what we're measuring. We're going this way. So these are the ones that we're trying to get something on, and we weren't getting them on the board we're working on. So, but this ACOK, don't know where that resistor is. Is that PR1911? But why is it 1921 on here? That's why I hate the schematic stuff. I mean, you know, all this stuff is kind of like bootleg in a way. Oh, thank you. Thanks for the donation. Take a break and continue fixing. Yes, I probably need to take a break. But anyway, I'm kind of ranting on that. I just wanted to figure out what voltages we had here. We'll go ahead and get this transferred over so we don't wait any longer. And once we get it on there, we still haven't replaced this chip, but we can replace this one while we're at it if we want, since we have it right here. Again, I can't see the camera, so we're going to go ahead and get that replaced, and then this is the MOSFET we hadn't replaced either. But we at least know that these work because they did turn on. Hydrate, yes. I've been talking about a sip of water for a while, and I haven't taken a sip yet. I am starting to babble, I guess you can tell. So I'm going to pull that off, and I'm going to pull this one off. Okay. Alrighty then. Okay, so we have it ready to go. And will it work? I don't know. We have our new chip here. I hope everyone's having fun, even though I'm failing miserably. Now, I'm not retaining the bottom of this chip because it just came off that other board. So that's nothing to worry about. So we're just going to heat this up, ready to come in, get that set there, tack it in just a little bit. I want to move out of the way once I get it tacked. I'm going to add some more flux. There we go. And look at that. This is exactly, it's a happy little chip. That's what we want. We want it to do that. You see how it kind of like went back into its spot? You can kind of tap it, it goes. I'm going to take my water break while I'm thinking about it. Okay. Carry on. All right, I'm going to stop this poll. What was the poll for anyway? Yeah. Okay, that's done. And we still have that other MOSFET we need to put on there, but it doesn't really matter right now. All right, we're going to plug it in. Watching my nightmares calms you? Oh my gosh. Oh gosh. Yeah. I guess it would be boring if it was quick and easy, right? You're like, oh, well, I just changed that chip out and there you go. Wada boom. Okay. This would be awesome if this worked. 3, 2, 1. We know it's not the problem because it's doing the same thing. Anyone recommend a good solder blower station? Hot air station is what you're talking about. And the hot air station that I use is this one, and this is a good one right there. You can see it. Okay. Let's figure out what voltage, I don't think we're getting those voltages that we were supposed to be getting, and I wonder if we put the voltage there if it will turn on. So right here we weren't getting anything. Right there we weren't getting anything. So where does that go? Does it go to this resistor right here? And what do we have here? Are you guys getting this? I got 5 volts right here on this side, and I got 0 volts on that side. So does that mean that this is pulling it low, or does that mean that this is burned out? Does it have a little dot? Is it winking at us? It might be winking at us just a little bit. So if I measure across it, it's in line, so you can't really measure across it, but let's see what we have here. When it's on the board, you can't really get an accurate measurement, but if it's a 0 ohm or a 1 ohm or something like that, something low, so it's saying it's a 100K is in that area. So if we take our other board and see what measurement we're getting across that, I guess we can see on the board view. That'd be easier. Was it this one? 100K. So it's measuring correctly. So that means that we have 5 volts here, and then we were measuring, it's supposed to be like 3.3, I thought, on here for ACOK. And what is that? So we were getting, so VDD is the 5 volt line. Okay, so that's why. So we have 5 volts on this side. So this is where it has to pull high, is right here. So we're not getting our pulling high. Let's just, I mean, see, I like the Soren's approach on some of this stuff. It's like, it doesn't have 3.3? Let's put 3.3 there. So that's what I'm going to do. So let's get our power supply out and put 3.3 there, or we can just measure on the other side. We might be able to jump it. Let me measure on the other side of this diode or whatever it is. What looks, yeah, the board's looking pretty funky in general. It's getting pretty dirty because I'm not cleaning up after myself. All right, so I have the power supply plugged in again. I'm measuring the voltage right here, which we should have 3.3 for our ACOK, but it's not there. We don't have anything on that side, and we don't have anything on that side. Don't have anything there, don't have anything there. So we're not getting our signal. And then this is coming from our VDD. So what do you think? You think we should just put our voltage there? That's what I'm going to do. Let's set up the power supply real quick. Give the board a clean. You think that's going to solve the issue? Hey, look, I already have 5 volts in there, but I went at 3.3. Yeah, the MOSFET doesn't matter that we don't have on there because it's parallel with another MOSFET. So it can't tell the difference. But I will put it back on there. Voltage plus thermal camera equals fun stream. Right, I'm going to inject 3.3 on that line, and we're just going to pay attention to our power meter. Actually, I need to, well, let's see, I can't do them both. So we're either going to look at our power supply or we're going to look at the power meter. Can't do them both, but I need to look at the power meter. So that's what we're going to do. So USB-C is plugged in. I have 3.3 on there. Let me make sure we have current limit. So I'm only putting 185 milliamps. And go. So now, so it's pulling the max of 165 milliamps. So now we can put our thermal camera on it and figure out if something's shorting. I guess so. Let's do that. Give me a second, guys. I gotta answer a message here. My wife's messaging me. Okay, let's get the thermal camera set up. Yeah, probably only going to give us about 20 more minutes because it's almost 9 o'clock here, and I will go home. So let's just wrap up what we're doing, this final thought, and then I'll probably call it for the night. But and we didn't fix a board, which is hopefully still entertaining. But all right, the thermal camera is booting up. It's thinking about, oh, I didn't hit the power on it. Thinking about it. So the thermal camera I'm using is just a Flare 1 Pro. It's a medium priced camera for a phone, and then I'm casting it to my computer here. So all right, so we have a hotspot, but what is the hotspot? Do we have a hotspot? We should have a hotspot if it's the what is it? The PD controller. Yeah, I'm starting to not be able to talk. A PD controller for the USB-C. You can see it getting warm. It's kind of getting warmer than I would think. What if it has a bad one of those and it's messing up everything? Huh. That'd be crazy. If that's been... I'm not sure it's open. Yeah, that's a little hotter than I would think it would get. Here's another board. So this is a different board. And you see how hot that PD controller is getting? It's definitely not getting as hot as the other one. Let me plug in the barrel jack and see what that one's doing. See if it's creating any other heat. And then we're going to inject that 3.3 on that ACOK, which I'm suspecting there's some sort of short over there. Barrel jack's plugged in. I'm not pointed at it, so you can't see any current. There's no current. Nothing's getting hot because it's not going to pull any current from that. But ACOK, let's inject that and see what happens. So we are injecting right here. Okay, so that's backfeeding into the power management chip, which we know is okay. I don't know. I don't know. I don't know. I'm going to give up on this one for right now, guys. My brain is just fried with that. Yeah, we can do Corey's real quick. And that way we at least get something successfully done, and Corey will be happy because he's been waiting patiently, haven't you? Corey, is Corey even still here? Corey may not even be here anymore. Yeah, I think there's a resistor open somewhere also. All right, I'm going to do Corey's real quick, and then we can call it for the night. Let me go grab his. Corey, you're here. All right, awesome. Okay. Someone update the note on the top, on the comment of what I'm about to do, and then I'm going to pin it up there. I'm trying to find his. Sorry, there's a bunch of machines here. There we go. Okay, Corey, I got your laptop here. We'll show you what the symptoms are, and then we'll show you the solution. And let's hope that I don't run into an issue and eat my words, eat my shorts, because it doesn't work. So I'm gonna hit the power button here. I gotta update my other thing. So I'm gonna update my the model that I'm working on the screen. Okay, all right, and then did somebody post something of what we're doing? Sorry, I'll go back up a little bit. All right, I'll look back in a second. Okay, so I'm hitting the power button, nothing's happening. It's probably dead or something, so let me plug in the power. We are pulling 0.05, then 0.02. Hit the power button. It is coming on. And it's coming on. We have picture. All right, so here's what I want to show you. So we're going to go into the BIOS first, just so we can kind of look around. Let me make sure Corey doesn't have any stuff here. Corey, is it okay if it says your last name here? Because your login has your last name on here. Otherwise, I can try to cover it up. But oh, it is your name there. Okay, perfect. Cool. All right, so we have his name here. All right, so what? Keyboard doesn't work. Okay. So we can plug in a USB keyboard. The whole side of your case is busted over here too, Corey. What have you been doing to this machine? USB keyboard plugged in. I can type. I don't know what your password is, so it's not going to be very helpful, but So the keyboard's working, okay? But this one does not work. Oh wait, it is working right now. So it does come and go, right, Corey? It's not always, it doesn't always do it. So right now it's working. See? Because this is how this works. So I can reboot it and it will stop working. Uh-oh. I typed too many numbers too many times. I was wondering if you gave me the pin. You didn't give me the pin. Okay, so let me... Corey, what's your password? Yeah, let's go ahead and publicly post that. I'm going to reboot it real quick. We're going to go into... I can put a test operating system in here, Corey. Don't worry about it. I don't need your stuff. Oh, well, there you go. There's your pin. All right, so let me write that down. I guess a pin isn't that secure anyway, right? 0, 2, 3, 3, 6. Okay. Yeah, the hardest problems is whenever it's intermittent, and I've seen people be able to make it go away by like changing settings, power settings, and things like that. But so the keyboard's working right here, no problem, right? But what I wanted to show you is whenever it's not working and what to look for when you have this issue, okay? And that's assuming we're going to have this issue, and it's funny because it's not showing the issue up right now, so. Outside of Windows, it's working. Joe's password is password. That's about the same as just having a blank password. All right, keyboard's working again. So this is going to eat your shorts type of situation here. So we're going to go to Device Manager. And this is what I want you to look for. See if I can zoom in. And I can already see that there is an issue there. So, okay. I'm going to scroll down. Can't see where the mouse went. Did we just lock up? It's not working. It just locked up. Corey, what's going on? What's going on with your computer? My USB keyboard's not working. The touchpad's not working. And it's whenever I move the machine. Are you having any intermittent lockups when you move the machine? Oh, touchpad is disabled, but the USB keyboard's not working either. Here, I'll plug in a mouse. Let me go grab a mouse. Just want to verify that we're locked up because the touchpad was working. All right, so I have a mouse hooked up. Yeah, it's locked up. Let me just reboot real quick. It was right when I tilted it. So yeah, I unplugged the USB keyboard. Now all I have plugged in is the wireless dongle for the mouse. But what I was trying to do is I was just trying to scroll down. You can actually see my cursor is right there in the corner. I was just going to try to scroll down on the device manager so you can actually see the error that's inside the device manager that you know that the USB device is not working. Try this again. Does caps lock work? Yeah, whenever we have this issue, it's always because the USB device is labeled as an unknown descriptor in Windows. I mean, it's still working. I can't believe. Oh, so you don't even have an unknown descriptor in here. You have some errors in here, though. I'm going to try to zoom in again. But I can't tilt the device back very far in order for you to see it. Let's do that. Some reflections, some mad reflections here. So what we're looking for is actually an unknown USB descriptor in here, and I'm not seeing that. So what I do see is I see that this device right here is disabled. It's a I2C HID device, so human interface device. I don't know what that is, so we're going to re-enable that anyway. Not sure what it is. And then you have another, your Dell Data Vault Control Center is messed up, so I'm just going to delete that out of here, hit uninstall, and then we'll just rescan for those devices. And then you also, okay, you have your touchpad disabled, that's fine. I could see, because it's the HID device, compliant device disabled. So, all that's good. Let me restart the computer one more time. Just want to see what changes. Yeah, the fans are just going crazy. Do you have it set on like overclocking or anything like that? Is it hot? Does it run hot? The fans are not playing around. Now they're blasting even higher. I'm going to go in the diagnostics real quick. I just want to see what is up. And it's like the screen's getting blown out. I'm trying to, there you go. We're just going to run the diagnostics real quick. When it moves, it freezes, yeah, because it was like, it did lock up when we moved it. You may have some other issue. It may not even be the issue that we're talking about. Yeah, it is. The trackpad is RGB. All this stuff's RGB. It all ties together. So the trackpad, the backlight of the keyboard, so it's an RGB LED. It can go across like that. So all of this stuff hooks to an MCU board that controls all of this. That's blasting the fan some more. We're only pulling 126 watts out of the charger though. I have a 240 watt charger plugged in. This thing requires a 330. Cable connection issue, it might be. I had one of the, you also could have liquid metal leaking in here. This machine has that issue a lot too. But that would mean it not turning on most likely. Oh, yep, Marty, you said it at the same time as me. Repaste it. Yeah, I mean, it's blasting. I could stop this in a, you know, we don't need to run the whole thing. That way you can see what the temps are, because I bet it's running hot. No, it's running cold. Can y'all even see that? Gosh, it's so blown out. The CPU is currently at 55C, and it hit a max of 62. That's crazy cold. But it's still just blasting. So I'm assuming you have this thing in like performance mode in the BIOS, which is like overclocking. So let me go back and we'll pull that up. Which I don't like performance mode. It makes this machine run all funky. We'll come over to here, come all the way down to the bottom, and you have performance options. No, you have it disabled. Crazy. So is it like not reading the fans properly? No, because it didn't have an error with that either. Yeah, the fans are starting to crank some more. What BIOS version do you have? 128. I think it's on, that's close to new, or close to recent. Yeah, something's whack. Something's whack, yo. Multi-key function, backlight. I don't know. I'm gonna have to take the whole thing apart and rebuild it. That's what I would do is repaste it, go through and just rebuild it and see if that fixes the issue. The fans don't seem dusty. The temperature of the CPU is not hot at all. I mean, I'm running at a lower wattage CPU, I mean a power supply, so the CPU is not. And it might be PQ 1900 still. That's funny. I would flash the BIOS. But we should do a BIOS recovery on it. Okay, let's try this again. I just want to see if anything popped up. Okay, so the only devices now that are disabled are going to be touchpad related. So this is the HID compliant touchpad and then the HID compliant mouse. And then everything else is fine. Those are disabled, but I'm not seeing that issue with your keyboard. So when is that going to happen? Yeah, the fans just slowed down too. You're right. Now the fans are quiet. I don't know. Corey, I don't know, buddy. This is gonna be a mess with it. Probably rebuild the whole thing. But it is 9 o'clock, and I'm turning into a pumpkin. I'm tired. I need to go home and eat dinner. I can barely speak. Run Windows repair, maybe. I would probably, instead of running Windows repair on this type of thing, you could do all the chipset drivers, make sure all the power management stuff's up to date, update the BIOS, and then see if it still does the issue. But as for the keyboard issue, I'm not seeing it, Corey. I'm sorry, buddy. But we'll mess with it. I'll put it on the test bench. We'll try to see if we can make it happen. What I usually do, I have had one come in that was intermittent, so I didn't really see it. I just changed it out anyway, and that way they don't have to worry about it. Changed out that choke. When's the next live stream? Every Wednesday at 6 p.m. Central Time, but I'm going to be out of town for the next 2 weeks, okay? So you won't see... I'll try to get video up next week and the week after, probably only one video. No live stream next week and no live stream the week after that. So it's going to be 3 weeks from now will be the next one, all right? So sorry about that. But it says it recognized an undersized AC adapter because I'm running a 240. Anyway, but I appreciate you guys. Yeah, it's been 3 hours. I am exhausted and we didn't accomplish anything. So... hooray! But we had a great time, right? So, anyway, I hope you guys had fun, and thanks for watching.
I saved another laptop!